However, we physicists say that the universe was created in a Big Bang 13.7 billion years ago. But then the question is, why did it bang? What set off the bang? For as long as we've been studying science and the history of our universe, the Big Bang has been the explanation for it all. There have been hundreds of studies, thousands of scientists have worked on the research. From what data has always said, the Big Bang has been the leading theory that proved how the universe was made. That energy is dark energy. There is an energy source even bigger than galactic, and dark energy is the energy of the Big Bang. It is the anti-gravitational force that's creating the expanding universe. But science today is a lot different than what it was back in the day. With technological improvements come new theories, and more often than not, we find out that things we believe to be 100% true are far from it. Well, it might have just happened again. Mokaku is finally talking about it. The Big Bang has officially been debunked as the James Webb telescope has detected 750 new galaxies, and they're nothing like what they should be. Join us as we dig deeper into what the James Webb telescope found and how it changes everything we thought about the way the universe came into being. At first glance, the images of the new galaxies taken by the JWST look absolutely breathtaking. You can see hundreds of galaxies all in the same frame, and the sheer power in the photos is something you just can't ignore. But that's what things look like to the average person. For researchers, things are the total opposite. These pictures are surprising, to say the least. They don't match what scientists thought they would see based on their theories. In fact, they're seeing way more galaxies than expected, and these galaxies are different in some surprising ways. They're smooth, smaller than imagined, and really old. All these surprises are causing a bit of a panic among the scientists. One paper even starts with the word panic in its title, so you know things are serious. The galaxies look nothing like what they're supposed to. Scientists have put forward the Big Bang theory as the leading explanation for the origins of our vast universe. According to this theory, around 14 billion years ago, the universe came into existence through some sort of mysterious cosmic event. It's the ultimate birth story of the cosmos. The surprising nature of the images captured by the James Webb Space Telescope has challenged scientists' understanding of the universe's origins. The hypothesis that these images directly contradict is the Big Bang hypothesis, which has long been regarded as an unquestionable truth by the majority of cosmological theorists. These galaxies appear to be too small, too smooth, too old, and too numerous when compared to the predictions of the Big Bang hypothesis. The small size of the observed galaxies entirely contradicts the expected behavior in an expanding universe. According to the hypothesis, as the universe expands, objects should appear larger with increasing distance. Yet the JWST images show galaxies that are 2 to 3 times smaller than similar galaxies observed using the Hubble Space Telescope. This discrepancy challenges the notion of an expanding universe. We don't actually envision that the universe is expanding into some pre-existing container. There's also the fact that the smoothness of these galaxies is totally unexpected. The Big Bang theory suggests that galaxies should exhibit irregularities and variations in their structures due to the dynamics of their formation and evolution. However, the JWST images reveal galaxies that appear unusually smooth, lacking the expected level of complexity and roughness, which is what you'd normally expect to see in the images. The age of the observed galaxies also seems to be incredibly strange. The JWST observations indicate the presence of galaxies that appear to be unexpectedly old. This challenges the expected timeline of galaxy formation and evolution within the framework of the Big Bang theory. Plus, there's also the fact that the abundance of observed galaxies is a lot higher than what it was supposed to be. The Big Bang hypothesis predicts a certain distribution and density of galaxies based on the expansion and evolution of the universe, but the JWST images show a massive number of galaxies, which raises questions about the accuracy of the predictions made by the hypothesis. According to the Big Bang theory, at the very beginning of the universe, all matter, energy, and the building blocks of the cosmos were compressed into an extremely tiny and highly concentrated point. This point is called a singularity. This is a point where infinite density exists. When we say infinite density, we mean that the matter and energy within the singularity were squeezed together to such an extent that their density reached an infinitely high value. The concept of a singularity comes from our current understanding of the laws of physics, particularly the equations of general relativity proposed by Albert Einstein. Within the singularity, all the matter and energy in the universe existed in an extraordinarily compressed form. The extreme density implies that an enormous amount of mass and energy was concentrated within an infinitesimally small space. While the space isn't much of a problem here, when there's so much pressure and density, you've got unimaginable heat. The temperature within the singularity would exceed any temperature that can be observed or reproduced in our current understanding of the universe. The energy stored within this hot, dense point was the seed from which the entire universe would unfold. That's why the singularity marked the beginning of the universe as we know it. It was the origin from which everything in our cosmos most came. After the initial singularity, the universe started the journey of expansion and inflation. This process occurred over the course of approximately 13.7 billion years, shaping the universe as we know it today. The expansion of the universe started with an extraordinary burst of rapid expansion known as cosmic inflation. During this phase, the universe expanded at an unimaginable rate, far exceeding the speed of light. It's like the fabric of space itself was stretching and stretching, taking everything within it along for the ride. Cosmic inflation played a massive role in shaping the large-scale structure of the universe. It smoothed out irregularities, homogenized the distribution of matter and energy, and set the stage for the subsequent formation of galaxies, stars, and other cosmic structures. As the universe continued to expand, the rate of expansion gradually slowed down. But with this information, it's important to note that even though the initial period of cosmic inflation ended, the universe continued to expand at a measurable rate. This ongoing expansion is known as the expansion of the universe or cosmic expansion. Scientists have observed the effects of this expansion through various observations, such as the redshift of light from distant galaxies. The redshift indicates that as the universe expands, light waves get stretched and shifted towards longer wavelengths, shifting them towards the red end of the spectrum. While the expansion was happening, we basically had all the stuff that makes up our universe squeezed into an incredibly small volume. It was clear that matter cannot survive in space like this, so something had to give. As the universe expanded and cooled down, transformations took place. Particles such as protons, neutrons, and electrons began to interact with light and energy in their surroundings. These interactions played a pivotal role in shaping the formation of matter in the universe. During the first few minutes after the Big Bang, there was a process called nucleosynthesis. This process involved the creation of lightweight elements like hydrogen and helium. The extreme temperatures and conditions during this phase allowed for the fusion of protons and neutrons to form these simple atomic building blocks. Hydrogen, the simplest and most abundant element in the universe, was formed primarily during this early period. Helium, the second most abundant element, also emerged during this time. These elements were instrumental in setting the stage for the formation of stars, galaxies, and more complex elements that would come later in cosmic history. The synthesis of these elemental building blocks was a significant milestone in the evolution of the universe. From a primordial sea of particles and energy, the early universe transitioned into a state where matter actually began to take shape. This process laid the foundation for the rich diversity of matter and the vast cosmic structures that eventually came into being. Now, the Big Bang theory might seem like wordplay, but it's supported by a lot of compelling evidence. The Big Bang was an interesting event, but not the first event in the totality of reality. One of the most significant pieces of evidence for the Big Bang theory is the discovery of the cosmic microwave background. The CMB is a faint radiation that fills the entire universe and represents the afterglow of the Big Bang. This cosmic radiation was first detected in 1965 and has since been studied extensively. The characteristics of the CMB align closely with the predictions made by the Big Bang theory, providing strong confirmation of its validity. The observed pattern of the CMB radiation, including its uniformity and temperature distribution, supports the idea that the universe was once in an extremely hot and dense state before undergoing expansion, which, as we've discussed earlier, was one of the main events during the Big Bang. The presence of the CMB provides a remarkable glimpse into the early stages of the universe, serving as a direct echo of the initial moments following the Big Bang. Its discovery and subsequent analysis have played a crucial role in cementing the Big Bang Theory as the perfect explanation for the origins of the cosmos. In addition to the CMB, other lines of evidence further prove the Big Bang Theory. You've got things like the observations of the red shift of light from distant galaxies that provide evidence of the expanding universe. The observation that galaxies are moving away from one another in all directions suggests that the universe is continuously expanding as predicted by the theory. The abundance of light elements such as hydrogen and helium found throughout the cosmos is also consistent with the predictions of the Big Bang Theory. The large-scale distribution of galaxies, which has been revealed through astronomical surveys, matches the predicted patterns emerging from the Big Bang Theory. As astronomers have meticulously observed and mapped the cosmos, they have discovered a striking pattern, the clustering of galaxies in a way that aligns with the predictions made by the Big Bang Theory. This clustering is not random, but instead follows a specific distribution pattern known as the cosmic web. The cosmic web consists of vast filaments of galaxies and matter separated by immense voids. This intricate structure provides crucial insights into the dynamics of the universe's expansion and the formation of galaxies over billions of years. The observed large-scale distribution of galaxies supports the idea that the universe evolved from a hot and dense state and underwent expansion, eventually leading to the formation of cosmic structures. The uniformity of the cosmic microwave background radiation, the red shift of distant galaxies, and the distribution of galaxies in the cosmic web collectively provide a comprehensive and consistent framework that aligns with the Big Bang Theory. Supported by a wealth of evidence, the Big Bang Theory remains the prevailing cosmological model. The new galaxies that the JWST discovered are super redshifted, which is why scientists were able to see them in the first place. Since space is expanding, the light from distant galaxies gets stretched out, making it redder, hence the term redshifted. If a galaxy has a redshift of 10, it means we're seeing it as it was when the universe was only around 500 million years old. Some of the newly discovered galaxies have a redshift of 13, which is really close to the cosmic microwave background radiation from the early universe. Scientists were pretty confident they had the universe figured out until they saw these new galaxies. There are way more than anyone expected, especially considering their size and age. These galaxies are supercompact, which is not what you'd predict from the Big Bang Theory. According to the theory, galaxies were supposed to grow gradually over time as gas turned into stars. The new discoveries have left scientists scratching their heads. The main issue with the Big Bang Theory is that it suggests a chaotic start with random clumps of gas forming galaxies that gradually grew larger. The galaxies seen by the JWST are way too smooth and well-formed for that theory. Some researchers are saying we might need to rethink everything we know about the universe. The James Webb Space Telescope has shown us that there are galaxies that defy the traditional understanding of the Big Bang Theory. These new observations have opened up new questions about how galaxies form and grow over time. One of the primary issues is the inconsistency with the Big Bang Theory's predictions. According to the theory, galaxies should have started as small, irregular clumps of gas that gradually coalesced into larger structures. However, the galaxies observed by the JWST appear to be far more smooth and well-formed than what the Big Bang Theory would predict for the early universe. This unexpected smoothness and structure suggest that there might be more to the story of galaxy formation than previously thought. Furthermore, the discovery of galaxies at such high redshifts, which means they existed when the universe was very young, raises questions about the timeline of galaxy formation. The JWST has detected galaxies with redshifts as high as 13, indicating that they existed when the universe was only a few 100 million years old. This challenges the current understanding of how quickly galaxies could form and evolve. In light of these new observations, scientists are now faced with the task of re-evaluating the existing models of galaxy formation and exploring new theories that can account for the discrepancies. This might involve reconsidering the processes that drive galaxy formation, the role of dark matter and dark energy, and the fundamental principles of cosmology. In simple words, everything you know about the Big Bang Theory might not be true, and the universe might be more complex and mysterious than we ever imagined. The universe is a giant ice cube from this angle. If you chop off one corner, the ice cube still looks infinite. What happens to parallel universes in this model? If the universe were infinite, there'd be an infinite number of parallel universes right in your room. To begin with, these parallel universes are on the next atomic level, not big cosmic objects. Scientists are doing research to figure out how many parallel universes exist. If true, the origin of the universe becomes less clear because there can be many Big Bangs. The work done with the JWST has raised doubts about the universe being created from one Big Bang. All these new questions are very exciting because they encourage us to think outside the box. They force us to reconsider old ideas and come up with new ones.